Well, good morning, class, and we had kind of an unexpected snow day today, so I am recording your lesson on polynomial to polynomial multiplication. As you can see on the screen, I've decided to provide you a work check for your classwork 166 to make sure that you are doing your monomial to polynomial distribution perfectly and you are getting to the right results. I've also provided you an answer key to your homework on here. So you can check your work and make sure that you're progressing correctly and in the right direction as we lead into polynomial multiplication. Now, if you would, make sure that you have your warm-up and notes out in front of you so that we can take some good notes and have some lined paper for taking some notes as well as we go through the lesson today. And you can pause and check your work, but we are going to move on and we are going to get into the warm-up. Now with the warm-up, I'd like you to do these top four because this is a refresher on monomial to polynomial multiplication. Remember to show your steps as you go along. And when you're done with those four, go ahead and press unpause, but pause me now and get through those four problems, please. Okay, well, we're going to go ahead and go over these and making sure that we set ourselves up wonderfully for moving on into the higher level work. So let's start with, we make sure that when we have a multiplier going into parentheses, that we correctly distribute the values outside the parentheses to the values inside the parentheses and rewrite and solve the problem. So we got 2 times n is the first monomial, and 2 times -5 makes minus 10 as the second part of the polynomial. Moving on to the next one, I made my life a little bit easier. I recognized that we had a monomial on either side of a binomial, so I simply multiplied the 2n and the 5 to kickstart things, and then I could distribute the 10n into the binomial and simplify. With the next one, we really have a multiply into a binomial and a multiply into binomial, but they are being subtracted in essence. So we really have two different distributions, a 2 and a -4 being distributed. The 2 to the n, the 2 to the -5, -4 to the 3n, and -4 to the -6. Now we make sure that we do the final step and combine our like terms. If you're catching on to all these steps, you'll have a much easier time today as we work through the problems. You're going to find that this right here is very, very similar to what we're going to be doing today. So let's try that one more time. We have a 2n and a 4 being distributed into two different binomials. And then we combine our like terms. You don't see any like terms here. So I could reorder by power of the variable, but we're just going to leave it as it is for right now. If you reorder, remember to use your commutative property and move the sign with the monomial following it. All right, now we're going to take these concepts and the understanding of a monomial to a binomial distribution and apply that to a higher level concept. What I want you to do, and you haven't seen how to do this, but I want you to try this on your own. I want you to consider that this 2 is being multiplied to this binomial and -x is being distributed to this binomial. Every time you complete a multiplication, it creates a separate monomial that needs a sign to separate it. So I'm going to show you this one. Let's see if you can apply it to this one. So let's go through. We're going to take this 2 and multiply it to the x and write 2x. We're going to take this 2 and multiply it to the -5 and write that monomial as well. Then we're going to take the -x and multiply it to x. And we're going to take the -x and multiply it to -5. And this is what it looks like when you write it out in full. You separate each one of the multiplication problems that we developed with a plus or a minus sign. So the 2 was distributed to both pieces. 2 distributed to the x, 2 distributed to the negative 5. And then the second part, including the sign in front of it, is also distributed to the x and negative 5. Negative x to the x, negative x to the negative 5. And I've separated each one of these multiplications by an addition sign. Now I can simply simplify each one of these monomials. And then I can combine my like terms. Remembering that we can order by power if we want to clean it up at the very end. So you try this one, press pause and try it. Okay, so hopefully you did the same process. We have a 3x times 3x and a 3x times 1. And then a 1 times 3x and a 1 times 1. Each item is being distributed fully. Then you simplify and combine your like terms. Well, this is our goal today. We're going to try to get a good handle on how we distribute a polynomial being multiplied to an entire another polynomial. It is rather complex, but based on your knowledge on monomial distribution, you should be able to extend that information. And just making sure that you keep the signs with the monomial following it is the most important piece as we go through. One thing that I like to reiterate at this point, because there are multiple steps in this process, please take your time, be slow and methodical as you're doing your work today until you get the concept down fully. Don't fear the size that some of these polynomials will produce. When you have a trinomial to trinomial, your initial line may have 6 to 9 different monomials being written out that you then have to simplify and work with. So we have a lot of larger problems coming up with us. And always be careful with your subtraction and negative signs. Remember to keep them, write out your negative negatives and change them to positives, and see how the signs affect all of the signs of the multiplication problem. All right. So at this point, I also like to remind students, if anyone has heard the terminology FOIL, you can forget that. FOIL is a bad word in high school algebra. That's a middle school term. It is definitely not what we do when we are distributing, because FOIL stands for first, outer, inner, last, and it only works for binomials. We are going to be dealing with trinomial and quanomial distributions, which produce multiple layers, and you cannot use that mentality. It is truly called distribution, and it's the same distribution we've always been working with. So let's take another example. We're going to go through many examples today. Make sure that you have a good handle on this. And let's take some notes on it. So we're going to show distribution, making sure that we go step by step. So first is showing the distribution multiplication problems, then simplifying the monomial, then shifting or preparing for combining like terms, and then combining like terms, and making sure that you have a final result that you circle. So let's start. Taking this particular problem, we have a 2x being multiplied to x. That same 2x is then multiplied to the negative 2. Then I take the second part, everything including the sign in front of it, and do the same process. So in this case, I'm going to take this negative 1, even though this says 2x minus 1. I'm really taking the negative 1 here and distributing it the same way. Each time I write a new monomial, I'm going to put a plus sign in between it. Notice that I did that here. I'm going to put another plus sign and then start with minus 1 times x. and then another plus sign, and minus 1 times negative 2. So when I have a binomial being multiplied to a binomial, not surprising, I get 4 monomials. Each one of these needs to be simplified and then combined with like terms. Let's try another one, a little bit more complex. This one is a binomial to a trinomial. Any guesses how many monomials should show up on my first line? Well, 2 times 3, we should have 6 when we write it out. And this is what I expect to see on your classwork and homework. The first layer should be the distribution line, showing that you are correctly distributing. So in this case, I'm going to take this negative 2x and distribute it to all 3 parts of the trinomial it's being multiplied to. Again, I'm going to put the plus line separator, and then I'm going to take the negative 1 and distribute it to all 3 parts of the trinomial. Now eventually, you're going to not have to show the full multiplication. You can just show the simplified version of this monomial, but we just want to practice and make sure that we're absorbing exactly what is occurring and why it's occurring. I simplify each one of those monomials, and eventually you will be able to go from this to this. But there should always be the first step of showing all 6 of the monomials, and then showing the step of those terms being combined and cleaned up. Notice I put them in power order so that I could make sure that I've combined all of the appropriate like terms. Okay, now I'm going to get a little bit more complex with this because I think you're probably getting the gist of it at this point. Everybody remembers this problem, I think, from our classwork last class, in which we had a rectangle and we subtracted the triangle in order to find the shaded area. The base times the height was the rectangle, and 1/2 base times the height, and we ended up with 3/4 MB for the problem. Well, now we're taking this to a much higher level. If we have a polynomial as one of the sides, how would we find the solution to that process? So we have to be able to take the process and apply it to word problems and geometric features and everything else that we'll be working with. It's the same type of process, though. Okay? We're going to take the base times the height, which is the larger rectangle, base times the height, and we're going to subtract 1/2 times the base times the height. So 1/2 times the base times the height. But now I have to be able to do polynomial to polynomial distribution. So this is the entire process. Rectangle minus triangle. Now I simplified 1/2 and 1/2 to 1/4 here. And what you'll notice is that we have 1 full minus 1/4 full, but in the end, that'll help you to understand that we should have 3/4 of our final answer of this. Let's go ahead and go through the process of distribution, distribution. And you have to rewrite. Oh my gosh. Takes up the entire page to rewrite that correctly. But that's okay. Everything can be simplified. As long as you understand the process, it's not difficult. It's just methodical, taking your time, making sure that you appropriately work through the problem. Now, you all know how to simplify each one of these monomials. And if there were any like terms, we would combine them, but there aren't really. So we have one of this polynomial and a fourth of the exact same polynomial, so we actually do have two like terms. This polynomial, and so we end up with 3/4. All right. We're going to try to apply this to a problem. So, Mr. Fitz wants to install a swimming pool at his hospital for physical therapy. He wants its length to be 4 feet longer than its width. That's a nice size pool. Then he wants to surround it with a grooved granite walkway 3 feet wide. If I can afford only 300 square feet of granite for the walkway, what should the dimensions for the pool be? So this is when we actually utilize the formulas to work backwards from a budget to what we can actually afford and what we can build for the money that we have available. What I need you to do is work through this problem with me so that you can attempt to do this type of problem later. So remember that whenever we get a word problem that has geometric features, we want to actually draw it out. And notice I've created one on the screen, but you need to redraw this on a piece of paper. You would have drawn a pool and a walkway around that pool. Now, we want you to label the pieces that you know. So let's see if you can label. Press pause. Okay. Now, you should have been able to label different sides of the pool. The width, and that the length is 4 feet longer than that width. And that each edge is 3 feet wider. Now, to set up the formula, we want to do the larger rectangle minus the smaller rectangle. And so what we get is the larger rectangle is really W plus 4 plus 3 more. It's the width plus 4 plus 3 more on this side and 3 more on this side. So it's really plus 6. And the width of the larger rectangle has this extra 3 feet. So it's W plus 6. Now the smaller rectangle, the actual pool itself, is the width and length. So it's W plus 4 and W. And it needs to be 300. Now, go ahead and press pause and see if you can actually work through this problem at this point, simplifying where you can, distributing appropriately, and see if you can bring it to a conclusion. And then I'll walk you back through it. So press pause now. Okay? So, hopefully you noticed that you could combine these before you started to go through distribution. And let's go through the process of appropriate distribution. You know how to do a monomial distribution, so W times W is W squared, W times 4 is 4W, and that would have been rather easy for you. However, this one would have taken the knowledge from today's lesson, and you would have had to distribute twice, and distribute twice, and making sure that when you subtract, you also distribute the negative. You would have reached this result. As you combine your like terms, you would have reached the result that W equaled 20. But was that what they were really asking? No, we also needed to find out what the length was. All right. Here's a general question, and this sometimes happens as we do multiplication problems. Can you combine these terms? think it through a little bit. And what happens quite often when we multiply terms in a distribution process is the variables get kind of messed up. But what I want you to recognize is that monomials can be combined as long as all the variables are to the same power and the same variables. The reason for that is I can use the commutative property to shift these around. So as long as I have an m, n, and a g, n, m, and a g, n, m, and a g, I can combine these terms. I just shift them around so that they look exactly the same. Commutative property of multiplication says that I can put this g at the back. It's all multiplication still. And therefore I can combine like terms and I would get 0. Alright. You have classwork. It is a very small amount of classwork because I want you to take your time, show each step, and get your work perfect. You have a small amount of homework with an answer key. I'm going to walk you through numbers 1 and 3 so that you can get a good start to the process and understand the levels that I'm expecting from you. So let's start with number 1. Go ahead and get out your lined paper. Make sure you put your name and the task number at the top. Number 1 looks like this. What I want you to notice is that I've highlighted the 2 terms in the multiplier. So that will help me to show you what I am really looking for here. My first line should show the full distribution. So, I'm showing that the x is being multiplied to the x squared in my first monomial. I'm showing that my x is being multiplied to the 2x with its sign in the second monomial. And I'm showing the entire distribution in my first line on my line paper. Next line would be simplifying those monomials. The last line would show the answer when you have combined all of your like terms. Okay, moving to number 3. We show the distribution. The one thing I would call your attention to is because this is a -1, when it gets distributed to a subtraction, we will always end up with a negative situation. Pay very close attention to those as you go through your processes. And simplify each monomial and get to your combined like term result. Alright, so I'm going to turn you loose to do your 168. Finish those few problems. Make sure you check your work on the screen here so you can pause the video to check your work when you are doing your line-by-line steps. And I've also provided on the next slide 169 and its answer key, just so that you know that this is also due as well. Now, we do not know what the schedule is going to be. I don't know if we're going to try to finish block schedule by starting Math 8 testing tomorrow or not. So I can't give you a good calendar of expectations, but you should be able to complete 168 and 169 by the next time we meet, as well as all of the other work that is due. So please add these 2 tasks to your work and have them ready to turn in after you have checked and made absolutely sure that you are correct with all of your answers. Feel free to email me if you have any questions.